Buenas tardes, vamos a iniciar el evento y en las charlas que se han programado desde este momento. Queremos indicarles que toda la información del evento está publicada en la página ciberseguridadec.org, incluidas las charlas de los dos auditorios, ahí pueden consultar los videos. A continuación, el señor David Piscitello nos hablará sobre los ataques contra DNS, monitoreo de DNS y cuáles serían las medidas correctivas. Él ha estado involucrado en la tecnología de Internet por más de 40 años. Sirve actualmente como vicepresidente de Seguridad y Coordinación TIC en la ICANN. Colabora regularmente con la seguridad de la información, las operaciones en una amplia gama de problemas de seguridad relacionada con los sistemas de nombres de dominio y los procesos de registro de nombres de dominio, incluyendo phishing, spam, ataques de DDoS, secuestro de dominio y abuso de registros. Ha escrito libros sobre protocolos de Internet, accesos remotos y voz sobre Internet Protocol Security. Publica artículos regularmente sobre la seguridad en Internet, DNS, anti-phishing, malware, la política de Internet y la privacidad.
Gracias. So it's my job to keep you awake for 40 minutes. Did everyone enjoy their lunch? Yes. Okay. This morning, I went into some detail about the kinds of attacks and the kinds of exploits that criminals look for in domain name system infrastructures. And I promised that this afternoon I would paint a less dismal view of the world and try to share with you ways that we collaborate today to keep the critical infrastructure part of the DNS secure, but also ways that, that any organization, even with as little an investment as a Raspberry Pi, can actually do quite a bit of monitoring for their own, for their own networks and to try to identify malicious traffic on the networks. So we're going to have sort of a very quick review of the classes of attacks that we talked about this morning, and then we're going to talk to you about how we detect them and how we might be able to mitigate them. So this morning we talked about authoritative name servers and recursors. The authoritatives were the name servers that host or publish the DNS information. And the recursors or recursive name servers are the ones that answer questions that are asked to the DNS or DNS queries. And they go and they ask all the authoritatives for that information. We talked about different kinds of exploits that were designed to either attack and cause name servers to fail, where they would not respond at all, or to attack them so that they could take over or own the name server so that they could use the name server for some other purpose. For example, to change an IP address and redirect a website to a defacement site of a government or of Google or of Microsoft or some other brand name. We also talked about the three components of many common denial of service attacks. There was reflection using IP spoofing so that you actually use as your own source address the address of your target. That way a recursor would actually send responses to your target. And then we talked about amplification, which was a way to send, to ask for responses that were very large, and again, using reflection, send those to the target. Right? And then finally, we talked about how using many, many sources of, for your attack, for example, a botnet, would allow you to do a distributed attack and have significant volumes of traffic directed at a particular target to try to disable that target or disrupt communications. We also talked about some cache poisoning examples, and we talked about some exhaustion attacks. We then also talked about attacks that can be performed or launched from any client computer, a mobile device, a laptop, a tablet, or even a server, are all possible victims of query interception, response modification, configuration poisoning, and some attacks that try to inject a particular packet that would cause the client to be disrupted or fail, just as we saw in the authoritative name servers. So what we're going to look at now is that sort of a systemic way to approach the risk that you face if you don't secure your domain name system infrastructure for yourself. So this would be your authoritative name servers, the recursive name server that you put out for your customers or your employees or your organizational members to use to query the DNS. And obviously, one of the first places that almost any risk mitigation or risk management exercise begins is by inventorying your assets. And assets aren't just computers. It's not just, you know, the numbers of software licenses. Assets are, in fact, how you are deploying your infrastructure. What kind of software you're using, whether you have diversity in software, where you've been deploying your name servers, whether you're hosting them yourself, whether you're hosting them off-site, whether someone else is hosting that service for you. And once you've done that inventory of what you have, what is running on those systems, who is managing them, where they're located, what kind of bandwidth they have, you've got basically a map of your domain name system infrastructure. Once you have that, you can begin to assess and mitigate what risks of attack you have. If you're running bind, which is a kind of domain name system software, there's a set of vulnerabilities that are well known. Are you vulnerable to any of those vulnerabilities? If you're using DNS not, which is a different version of DNS, you're vulnerable to perhaps different vulnerabilities. If you are using any of those name server software and you're running them on a Windows 2000 server, you're really in trouble, right? So these are all the sorts of things that you would go through very, very disciplined and try to identify where am I vulnerable, what part of my infrastructure am I vulnerable, and you check off the vulnerabilities. Okay? Now that you have that, you would actually go through a risk mitigation plan just as you would for any other part of your organization. Okay. In addition to planning and for your deployment to be as secure as possible and as resilient from attack as possible, you also want to plan for the inevitable attack, because there are only two kinds of networks on the face of the internet. One is one that has already been attacked, and the other one is one that is waiting to be attacked. Everyone is vulnerable. There is no perfect deployment. There's no bulletproof infrastructure. And we, after the past 5 years of seeing an escalation of so many attacks in so many places, we should all accept that as principle one and think about how we reduce our risk. So plan for the inevitability that you'll be attacked, and plan for your incident response. And how, if your incident response is in time before you are completely taken out of service, one of the parts of that planning is abatement. How can you reduce the nature of the attack so that you can cope? This is particularly important if you are looking at denial of service. Denial of service attacks can go on for weeks. There are now people who run denial of service as a service through a cloud. You can go and you can pay money at various places on the internet to have someone run a denial of service attack on your competitor. So, aware of all these things, you have to pay attention to the fact that you're going to have to face them, and it's important to be able to abate the amount of traffic while you try to squelch the origins. Another important part of planning is understanding when you need help. Okay, escalation means there's more here than I can manage. And what I need to do is have partners, have people who are going to actually help me. And in many cases, those are the same people that you are buying service from. Another very important part of resource and people planning is paying attention to what is going on in your own industry. If others in your industry suddenly become targets, for example, medical systems and medical companies and hospitals have now become targets, Months ago, after the first attack, if you were in the medical industry, you should have been paying attention to the fact that this might have been a change in tactics on attackers. So think about whether someone else in your industry being a target has caused for you to think about yourself as now a higher risk target. A very important part of being able to escalate and call for help is to nurture relationships among the people that are likely to be able to help you when you are attacked. And the kinds of people that are obvious are people who are in the business that you can pay to help you mitigate attacks. Okay, but some of the lesser obvious ones are the people who are providing your internet service, and not only the people who are providing internet service, but also those who provide internet service to the people who are providing you internet service. So you most likely have an access service provider. Anyone from a person who has a broadband connection in their home to an organization that has fiber coming into their facilities has an access provider. But there are also global providers that provide the backbone for the entire internet. Having contacts there and relationships there, if you're a very large organization, is critical. Okay. Whoever is selling you equipment, whoever's selling you software, your local CCERTs or CERTS are very important. Know that. You should have all those in your contacts lists, and you should understand how to get in touch with them through various medium, who to contact, who has your account, what your account number is. It's a ledger of what do I do when something goes wrong. Lastly, you should know what law enforcement has any jurisdiction over, over where you are operating and the kinds of acts that you are seeing. This is a very, very challenging process for all of us, but you have to start and get a good understanding early on. One of the most common problems that we see with every attack is that there's been a failure to do due diligence in configuring your some aspect of your network or your web servers or your clients, and keeping those configurations and their software up to date. It's pretty much of a sad fact that if you use something like WordPress as an example for your blogging sites or for your websites, WordPress is notoriously unsecured when it's deployed with its defaults. Yet I can show you one Google command where you can go out and you can find almost immediately 68 to 75,000 sites that all have the same default setting that all make them vulnerable to compromise, and they're all being used by illegal pharmaceutical affiliates. So universities, government sites, I'll show you afterwards. If I had an internet connection, I'd show you here, but I can show you the site, and I use this every morning. It's very unfortunate that we have a lot of people who are responsible for administering networks who are not sophisticated enough to understand all the details that they need in order to protect our networks. A very important part of actually restoring service after you've been attacked is knowing what your network was supposed to look like. So if a hacker breaks into your web server and modifies all sorts of things, and then you go and you rebuild the network, the web server from scratch, what did you want it to look like? Do you have any idea what it looked like? So it's very important to have what we call the last known working configuration and the last known working copy or trusted copy of the information offline so that you can restore your systems. Another important problem that I find whenever we've gone and helped some of the CCTLD operators understand or recover from an incident, which is one of the things that my security team does, is they don't know what their infrastructure looked like. They say, well, where were your firewalls? Where were your switches? How many DNS servers did you have? What IP addresses were you using? And they can't show me a document that says this is what my network looked like. Okay, so this is very, very important, because how am I going to reconstruct something if I don't have a blueprint? Domain names obviously are very important to ICANN's realm and remit. One of the things that we also find terribly lacking, even in some Fortune 500 companies, and especially in many large banks, is there is no single person in the organization who knows all the names that have been registered, who knows when they expire, who knows, who knows what to do if someone registers a name that is visually similar to, to the name that they use and then uses it for phishing. So if you don't have some sort of domain account administration and central brand management, whether you're a government or or even a small business that has more than 1 or 2 domains, you're setting yourself up for an attack where somebody can basically transfer your name out from underneath you, and getting it back is a non-trivial job. So make certain that you are prepared with documentation to prove that you're the licensed, the legitimate user of a particular domain name. And I have a number of articles on this at my security blog, securityskeptic.com, that that capture all of what I have on this slide and more. Another aspect where we shoot each other is not having our networks insulated from being sources of attack, as opposed to being targets for attack. I mentioned earlier that IP spoofing, using someone else's address or using an address that that doesn't belong to you, is a very, very common form of attack. Well, there are mechanisms that you can use in your own firewalls, and you can insist from your own internet service providers to make certain that no one can inject a spoofed or invalid address into the network from your network. That's called being a good citizen. And there's a standard called BCP, or Best Common Practice, number 38, that explains how to do this. We also talked earlier this morning about resolvers. These are the systems, again, that answer the question or ask the questions to the DNS. Well, there are 2 ways that you can operate resolvers. You can allow a resolver to answer questions on behalf of anyone, or ask questions on behalf of anyone, and that's called being open, or you can restrict your configuration of your resolver to only ask queries on behalf of clients within your own IP allocation, or the IP addresses that you have control over. The open resolvers are the ones that are most commonly used for these reflection and amplification attacks. So by implementing the proper safeguards in your resolvers, so that they're not run open and useful for attacks, you're actually helping us reduce the number of places where criminals can attack from. It's another technique that that you can investigate, or you can have your staff investigate, and it's called resource policy zones. And this is a way to essentially create a DNS zone file, a list of addresses and names that are basically blocklisted. So in addition to having your own zone data that lists all your websites and mail servers and name servers and their corresponding addresses, you have what's called a resource policy zone that you build from block lists that you would get from Spamhaus or from Serval or from others, that list all the domains that you don't want anyone in your organization to resolve. And I run one of these in my own home. I don't have enough to do, so I actually go and play with these things as well. And I run it on a Raspberry Pi. So it's, it is something that you can actually run fairly effectively and inside an organization, and reduce the exposure to known known dangerous sites that host malware, or that that resolve to spam relays or other places where you don't want people to visit. I think most people know the concept of defense in depth, but most people tend to think about defense in depth in the context of web traffic and mail traffic and mitigating spam and reducing denial of service. It's also something that is becoming more and more important for people who are running their own DNS service. So you can use DNS proxies, you can use DNS appliances, security appliances. or what they call protection appliances these days. And lots of firewalls are starting to have these kinds of features in them. The firewall I use at home is a Sonic wall, and that's not necessarily an endorsement, because I also had a Palo Alto, and both of those firewalls have features that allow you to do a significant amount of checking on inbound traffic to your name servers to see if that traffic contains exploit to fail attacks, for example, or that traffic contains or is shaped the way a denial of service attack might be shaped. One of the best things to do if you think you're going to be a victim of a denial of service attack, and we all are potential victims in this sort of extortionist mentality of denial of service these days, is add redundancy. And redundancy can be added in a number of different ways. So you can have redundant name servers. You can have redundant name servers behind redundant firewalls or switches. You can have redundancy by having the same kind of infrastructure in multiple locations that are geographically and carrier diverse. Particular to denial of service mitigation, one of the mechanisms that we use for the root servers, ICANN runs one of the root servers called LRoot, is something called Anycast routing. And Anycast routing is very, very powerful. I believe I have another slide. If not, I can talk to you a little bit about it here. It's also very important to segregate your service if you're running DNS services as well as other services. We investigated an incident last summer where a CCTLD operator was running web and the government mail system and the authoritative name service all on the same server. And so the web server was vulnerable to an exploit that gave the attacker root administration on the same system where name service was run, so he could then cross-service his attack, and he began attacking the DNS. He did a lot of defacements of major brands, Google, Microsoft, Yahoo, Apple. And then he found that not only this one CCTLD operator, but 7 others were using the same software and the same configuration because he just probed around. And so we had a spate of attacks all by one person who wasn't particularly clever. It's just that he found one mechanism to get into an organization. So service segregation is very important. We're going to talk a little bit about intrusion defenses in a minute, and we've already talked about redundancy and diversity. I promised you to talk a little bit about Anycast. It looks more intimidating than it actually is in deployment, but there are many switches and routers today support what's called Anycast routing. And what Anycast routing does is it allows you to use the same IP address in several different locations and have routing for the Anycast always resolve the traffic to the nearest instance of that address. So in this particular case, 192.168.11.1 was typically only 1 hop away from my internet user, or 2 hops away. When that link failed, I could go over to, in Anycast routing assures that I can go to a longer path but still get to that address, okay? And by doing that multiple times, I have resiliency around the globe. This means that your DNS service should never fail. And this is what we do at the root level and what many top-level domains do that are of substantial size to make absolutely certain that the DNS doesn't have a on-off switch, that you can't kill the DNS. And these have been very, very valuable when we have been looking at denial of service attacks on the ranges of 750 to 850 gigabits per second. I mentioned geographic diversity. This picture, although I'm sure it's a little hard to show, is all the places in the internet or in the globe where ICANN has LRoot servers, okay? And they're all Anycast addressed. So every one of these locations is using the same IP address. And the Anycast routing assures that those of you who are in South America are always going to the shortest distance IP or location of our LRoot service. This allows us to have very, very uniform response time and latency throughout our entire L-root service. We talked about that. I mentioned this morning that one of the ways to prevent cache poisoning attacks is to use something called DNS Security. And DNS Security adds two cryptographic services to the domain name system. One is integrity, which is a means to determine whether or not the information that you received was exactly the information that the publisher intended you to receive. Okay? And the other is authenticity. And this is a way to determine whether or not the information you received, the DNS message you received, came from the person you intended to ask for it. So DNSSEC does both these things using encryption, and we've added some mechanisms to the DNS protocol to actually go and do what's called sign your zone and have your zone signed by a top-level domain operator. Okay, and the top-level domain operators are signed by ICANN. So there's a chain of trust that allows us to determine that there's, the messages you're getting are authentic, and that by using a cryptographic mechanism called hashing, that the message is exactly the message that was intended to be delivered. So it works in this manner. First, as a publisher, you get your DNS data and you sign it with your private key. Okay. Then the signed data and the digital signatures are published in your DNS that you put out on the internet. Okay, this is what is on your authoritative name server. Okay. Now, since we're using public-private key cryptography, the public keys are in the DNS. They're in your zone. Okay, and the public key for the signing key is in the top-level domain. And so any traffic or any query that I would go through a validating recursive server, a server that's capable of processing the cryptography, okay, does what we talked before. There's the iterative resolution, goes to an authoritative name server. But now instead of just getting zone data, he's getting signed zone data. Okay. When those data come back, the validating recursive server validates with the public key. So if I'm I'm ICANN.org, I've signed my data with my private key, I've published my public key, okay, and now a validating recursor can say, let me see if this really came from ICANN.org. And he does that by using public key cryptography. And now he can pass it along with confidence that the information is exactly what ICANN intended to publish, and the information came from ICANN. So how does this defeat cache poisoning attacks? Well, the stub resolver is going to reject the attacker's data as not validated. Any organization, and these are, what we just did was a summary of the kinds of things that we do globally, and global deployment of things like DNSSEC, global deployment of security measures like eliminating open resolvers that are not secured properly and preventing IP spoofing would go a long way to reducing the attack surface. There are also things that we can do, for all our networks, independently of the global efforts, that would protect our own networks from attack. Okay, we want to protect our clients, as I mentioned earlier, from attacks like DNS Changer. So having malware, anti-malware, anti-virus software is one mechanism. But also having the ability to look at DNS traffic. The gentleman from Kaspersky this morning was talking about SEIM systems and was talking about gathering logs. He didn't spend as much time talking about real-time traffic capture. You can say real-time traffic capture is actually extremely valuable in complement to logging, because you can see as it's happening someone sending a malformed packet, or you can see as it's happening someone who's sending a suspicious pattern. So intrusion detection systems and intrusion protection systems inline are actually very valuable for doing this sort of thing. I think I'm not going to go over some of this because the gentleman from Kaspersky already went through it, and I want to try to put us back on track a bit. Again, making certain that resolver and host configurations are correct is important. Looking at DNS query and response traffic on networks is very important. Maintaining as much detail in your resolver and your authoritative name server logs as possible is extremely important. And there's also a service or a feature that you can now implement or you can subscribe to called passive DNS collection. And what passive DNS collection is it's a set of sensors that you can put out on your network, and you capture every query and every response that comes through all your resolvers. And then you map what it is that your users are actually visiting. And you can use that along with the OSINT, the open source intelligence, and other passive DNS collection to see whether or not your users are visiting sites that have already been identified as malicious, or to identify, for example, a particular IP address that's hosting not just one, but maybe hundreds of, of malicious sites. This is very common, particularly among illegal pharmaceutical affiliates. You can go and you can find that one name server is hosting several hundred, if not 1,000, names that are being used to draw people to illegal pharmaceutical sites or counterfeit goods sites or illicit sites where the content is either felonious, like child pornography, or highly damaging, like cyber terrorist radicalization and recruitment sites. So the kinds of things that we look for when we're doing analysis in our own networks is we look for spoofed source addresses, okay? We also look for all sorts of malformed or suspicious queries. And as I said, many firewalls are now starting to implement these. I know WatchGuard, I know Cisco, Juniper, Palo Alto, SonicWall, all have some forms of these kinds of features. What I think, from my experience, very few people turn these on because they're not familiar with them or they don't think DNS is a problem for them, okay? And even if you're not running a name server internally, you still can get a lot of mileage by seeing what your client traffic is going out to a name server. Message length anomalies. If you have never, if you're sitting and you've been watching your DNS traffic for a long time, and you've never seen a 4,000 byte response come into your network, that you should pay attention to that. If you suddenly see 4,000 of them, you should pay a lot of attention to that, right? Just picking out a couple of them. Known or malicious covert traffic patterns. One of the things that we started to discover about a year and a half ago, and we worked with Europol in a cyber operation where this looked like it was actually in play, is actually being used, is criminals are now using the DNS as a covert channel. They will pull down malware by asking for a text record from an infected computer using the DNS protocol. They ask for a text record, and the text record is basically a hexadecimal chunk of the malware that they're going to install, and the malware itself recompiles or reassembles a malware executable from DNS query responses. Okay. So there's lots of very, very interesting things you can learn, and you want to try to make certain that you see these by looking at your name server. One of the easiest ways to find out whether you have infected computers on your network is to look for name errors, names that don't resolve. Okay. Often, what happens if we've managed to take down a domain name that's associated with a botnet is that some of the infected computers still try to contact that name. And so if you have infected computers on your network that have been infected by and we've already cut off the head, the command and control, you can see exactly which IP address in your network is infected. So it's very, very valuable. I think we've covered some of these things. We've talked about traffic analyzers. We've talked about enforcing egress traffic for BCP 38. We've talked about excessive name resolution errors. A few years ago, ICANN Security and Stability Advisory Committee put together a report that explained the value of constantly monitoring your own zone, your published zone, going and querying and getting all the data and comparing it to what you intended to publish. And if you see any differences, you know that something's been modified without your authorization. It's a very, very simple script. You can write it in anything, and it can save you some very, very serious embarrassment, defacement, a loss of your domain, and the like. Okay. The same thing is true for your whois information, the record that's published that identifies that you are the owner and gives points of contact information should anything go wrong. If that information is changed without your authorization, that's another cause for concern. That could be very indicative of domain name hijacking. We talked about passive DNS. And so, in summary, there are 3 steps here. One is implement your in-depth defense, and that begins with doing a risk assessment and making certain that you understand what aspects of your name service are under threat, understanding how they're under threat, and then coming up with a plan to put up a defense and to mitigate those threats. Okay. A second important part is that you can't do this yourself anymore. The DNS is a distributed system. You need partners. You need to understand, and even with just your network connectivity, the same is true. And then the last, which may actually have been more useful first, is your soft planning, the people in the administration, and keeping track of things like your domain portfolio and your IP allocations and your resources and assets are all very, very important. This is a partial list of articles that I or some others have written about almost everything that we've talked about today. So if you're the kind of person who learns by reading, this is just the surface of the kinds of attacks that you want to look at and the kinds of remedies. My site, www.securityskeptic.com, has about 400 articles that I've written over the past 10 years. Most of them are about DNS and about malware, and there's probably something something that you would find that you probably haven't looked at yet if you go and you take a look at that site. And I also love to link to other really, really good people, so you'll also find some really, really valuable redirects to some other excellent security people. Thank you very much. If you have any questions, we can answer them now, or I'll be here all week, and I'm happy to talk with anyone. If you want a copy of the presentation, I've already put up a copy of this morning's presentation on my website, and I'll have this up by 6 o'clock this evening. So thank you again, and I appreciate having me here.
Les queremos indicar y recordar que los